Okay, we're going to look at graphing y equals ax squared. So we're going to only look at graphing the first part. We're going to look at graphing the base function, as we call it, of the parabola. So let's see our joke of the day here. Slope. So you have to rise before you can run. And track meet. And these guys are sleeping. Okay, could be a bit better. It's difficult to find these jokes. Okay, first, question 1 here, and I want you to fill in this table. Using the quadratic equation, create a table of values. Okay, and then we're going to graph that table. So I'll show you how to set up this table here. So y equals x squared. So in here, we'll put -3, and we'll put squared, and we'll figure out -3 times -3 is 9. And we'll put -2 squared, and then 4. Now, you can pause the video and fill in the rest of that table. Okay, now I filled in the rest of the table. You can pause and fill it in. It's 9410149. Now we're going to go and graph it. So I've done all the work. Now we're going to go graph it. So at -3, we're at 9, then 4. So let's do my best here. I'll try with the mouse this time. At -3, we're at 9. So we're going to put a dot at 9 here. I'm going to put a dot right here. And then at -2, okay, we're going to put a dot at 4. And now at -1, okay, we're going to put a dot at 1. At 0, we'll put a dot of 0. Put a dot right there. And we'll go to the 1, we're just graphing those points. And we'll graph this point. And we'll graph that point. And there you've drawn your first parabola or quadratic. I'm going to use my pen here, and as best as I can, I'm going to draw it up. It's in purple through the dots. And then over here on the same side here, I'm going to put this up. Okay. It's a little easier on paper than it is for me. Add the 2 arrows at the end. I do want you to do these by hand. Okay, so there's that graph. Okay, now I'm going to show you the step pattern here. Okay, I'm going to show you the step pattern and how it works. Okay, it's used to graph parabolas, and the step pattern is 1, 3, and 5. So I'm going to go back to this little graph we created. Okay, I'm going to come back here. I'm going to show you the step pattern. Okay, so the parabola first on both sides is the same. It's like symmetrical. So the axis of symmetry goes down the middle. Whoops, down there. So now I'm going to show with a different color the step pattern. I'll use blue. Every single time we're going to go move over 1. And then we're going to go up. So if you go straight up here, we go up by 1. Okay, the next step, we're going to always go over by 1. And now we're going to go up by 1, 2, 3. So there's the 3 in the step pattern. Okay, again, we're going to go over by 1. And then I'm going to go 1, 2, 3, 4, 5. Okay, so our step pattern, we always go over 1 and up by these numbers, 1, 3, 5. Same thing on the other side. You go over 1, up 1, over 1, up 3, 1, 2, 3, over 1, up 5. So 3, 1, 5. The 1, 3, 5 is an easy way to graph it, and it's known as the step pattern. Okay, it's used to graph parabolas. Now, this is what's known as our base parabola or base function. Now, it could change. This is our base. 1, 3, 5 is our base. Okay, but it can be transformed and changed in different ways. It can be moved to different locations. The size can change. Okay, can be transformed. The part can move into different locations. We were only going to look at the A. How does that A or a number in the front affect it? So we're going to change a number in the front. So instead, we're going to have maybe y equals 3x squared. Or we're going to have y equals -5x squared. And we're going to describe the change that the number in the front makes. Okay. So the role of A, what does it do? Okay. So A is a number in the front. So A can be any number. It can also be a decimal. It can transform it in 3 ways. It can do a vertical stretch, it can do a vertical compression, and it can do a reflection. So that A actually has 3 functions. It has the most functions of all the transformations we're going to use. Okay, now I try to explain it here. What to write for the transformation. So in the bold, it tells you what to write. When a is larger than 1, so a is greater than 1, the transformation is vertical stretch by a. Okay, when a is smaller than -1, so when it's a number that's negative, like -2, -3, -4, there are actually two transformations, and you write this. There's a reflection in the x-axis, and there's a vertical stretch by a. Now, when a is between 0 and 1, like a 0.5 decimal, the transformation is a vertical compression. It gets shrunk by a. And when a is between -1 and 0, there are two transformations as well. It's a -0.5. There's a reflection in the x-axis, a vertical compression by a. Now, I've put all this into a table here. So a reflection occurs when a is negative. A vertical stretch occurs, and here's some examples: -x, -2x, -10x. I could add another one here, maybe y equals -0.5x. Anytime there's a negative in the front, okay, it makes it open down or it reflects. There's a vertical stretch larger than 1. When it's larger than 1, there's a stretch. So when you got a 2, a 10, and a 100, like numbers bigger than 1, it stretches. And you can also have a negative here as well. So you can also have y, this will still be a stretch, equals -5x will also stretch it. Okay. Finally, there's a vertical compression for fractions. If you have decimals or fractions between -1 and 1, you get a vertical compression. The best way to actually see this is to do some graphs. Okay. And in order to graph, okay, we're going to use that step pattern, but we're going to multiply the step pattern by a to graph it. Okay, right now there's a lot of information to process. Hopefully, after we do 3 questions, you'll understand all this.